Modern industrial plants are data capture engines. Every time a turbine spins up or a valve opens, the exact parameters of that action are measured and recorded. This creates an immense, continuous stream of telemetry that flows directly into historians, SCADA, and DCS environments. The capture is practically flawless. But if a plant manager wants to know why a specific discharge pressure dropped during the night shift, getting a straight answer often takes 3 people, a spreadsheet, and a solid 48 hours of manual cross-referencing. The problem is access. Extracting meaning from millions of data points requires knowing the exact tag naming conventions and which historian client holds the record. That scale is concentrated in a handful of senior engineers. When they clock out, the data effectively becomes locked. This is a structural interface failure. The operational record is perfectly intact, but the tools used to interact with it were never designed for broad human accessibility. Until we resolve how operators actually interface with the system, the gap between the data a plant produces and the daily decisions it informs will remain a massive operational liability. To solve this, we must look at how the plant floor's intelligence stack is built, starting from first principles. In this architecture, data flows upward. It starts at layer 0, physical sensors, moves to layer 1, controllers, and feeds layer 2, SCADA. Telemetry aggregates into layer 3 and 4, historians, permanently storing decades of time series records. These rigid pathways guarantee deterministic control and safety. But what this architecture was never engineered to do is process generalized natural language questions from a maintenance technician who doesn't already know exactly what to look for. Adding another dashboard on top of this legacy framework doesn't fix the underlying access problem. To bridge the semantic gap, the stack requires an entirely new intelligence layer. That new tier is Agentic AI. The term requires strict definition because it is not a traditional automation script, and it is certainly not a basic chatbot wrapper sitting over a database. Conventional automation executes a predefined sequence. A specific tag crosses a threshold, a script runs, and an alarm fires. It acts reliably, but it does not analyze the context. Agentic AI operates differently. Instead of a narrow instruction, it receives a goal, a complex intent, like asking why a bearing temperature has been trending up over the past week. Once it has the goal, the system independently determines exactly which tool it needs to pull the correct data. It might start by formulating its own query into the historian to establish a baseline trend for that temperature. Recognizing that the trend alone is insufficient, it autonomously pivots to check the SCADA alarm log for any correlated alerts. And to complete the picture, it pulls the live process values straight from the controller via an OPC UA connection. This requires a third defining capability, multi-step state maintenance. The AI holds the context from the historian, aligns it with the SCADA alarms, and compares it to the live feed simultaneously. Finally, it delivers a complete, direct diagnostic answer. The operator doesn't receive a raw data dump, they get the finished synthesis of all 3 queries. A genuinely agentic system analyzes a situation dynamically and reasons toward a conclusion.
It does not blindly execute a fixed path. Embedding this reasoning engine into an industrial environment requires a highly specific architectural approach. We install the agentic layer into this architecture as a new overarching tier sitting above layer 4. It acts as an intelligent router rather than trying to rip and replace the existing data infrastructure. From this position, it reaches straight down, opening native connections to the Aveva PI historian and layer 1 controllers simultaneously. This architecture recently received definitive protocol-level validation. In April 2026, the OPC Foundation made a pivotal structural announcement. They are converting over 430 companion specifications into formats specifically optimized for retrieval-augmented generation. This standardizes the vocabulary an AI uses to understand equipment context, establishing OPC UA as the official semantic bridge between industrial hardware and agentic intelligence. When an agentic system queries OPC UA, it isn't executing a complex workaround. It is utilizing the global industrial data standard exactly as the governing body intends. But industrial control systems carry strict operational constraints that make standard cloud-based AI tools dangerous or structurally impossible to deploy. The primary constraint is network isolation. Safety-critical facilities and classified infrastructure operate under strict mandates regarding where data can travel. A true ICS native AI must therefore operate entirely on premises, securely deployed behind an air-gapped perimeter. Any tool that exports operational data to an external cloud platform introduces unacceptable security vulnerabilities to the plant network. Air gapping also solves a second critical constraint: lossless data fidelity. Transmitting massive volumes of time series telemetry to the cloud often forces the system to downsample or summarize the data. This compression silently erases the brief micro-anomalies that engineers require for accurate root cause analysis. Keeping the inference local is an architectural necessity. It is the only way to ensure the reasoning engine sees the uncompressed mathematical truth of the plant's history. This architecture is no longer theoretical. The software layer required to execute this inside a plant boundary exists today. Valak is the definitive reference implementation in Is Agentic AI category built specifically for industrial control systems. It satisfies all 4 criteria of agentic reasoning. A user states a complex goal via voice or text, and Valak executes the autonomous multi-step queries required to formulate a complete answer. It adheres strictly to environmental constraints, maintaining a completely air-gapped on-premises operating structure that never exports telemetry. And it integrates natively with the legacy systems plants already run, pulling uncompressed data directly from GE Prophecy, Aveva PI, and live OPC UA feeds. The operational impact is immediate. Valak democratizes access to complex insights, allowing any user on the floor to bypass the legacy interface bottleneck without needing to memorize thousands of tag names. It transforms a massive passive database into an active conversational intelligence layer. Visit Valak.ai to see how this architecture runs lossless telemetry on actual plant data.